Data visualization is a critical component of any data analytics class. But from what I've seen from my experience, most courses tend to focus simply on the construction mechanics, teaching students how to click buttons to simply build these visuals. But I've set my sights higher for my students. I don't want you just creating visuals. I want you to learn how to create highly effective data visualizations. And to do this, we're going to leave our accounting department for a short little time, and we're going to take a trip to the land of psychology. We're going to learn about principles of perception and design to learn about how we as humans perceive the world around us and how we organize chaotic stimuli into something meaningful. And the reason for this is that if we understand how humans process information, it can help us leverage those insights and create visuals that help us focus their attention on the takeaways we care about. Before launching into principles about how to improve our visualizations, I want to talk big picture about the objective and define what I mean by high-quality data visualization. Essentially, high-quality visuals are those that quickly and accurately communicate insights from the data. We want to reduce the amount of cognitive processing our audience is engaging in, so we want to help them arrive at the insight as quickly as possible. And honestly, it's less about what we do right than it is about avoiding faux pas. So let's talk about what are 3 key elements to highly effective visualizations. First, they use the right type of visual given the data and analysis objective. They also emphasize takeaways and simplify visual elements. Now with that first point, using the right type of visual, we've covered this in a prior video, so I won't address this process again here. Instead, we're going to focus on these second 2 topics, namely that takeaways are emphasized and visual elements are simplified. First, emphasis. This is the art of making important things stand out and unimportant things disappear. As it relates to data visualization, it is drawing your reader's focus to the insight or takeaway from a visual. We're now going to turn to the field of psychology to learn a little about how we as humans perceive the world. The specific branch of psychology we'll investigate is known as Gestalt. This was a turn-of-the-century school of thought originating from Germany, whose major theory suggests that humans naturally perceive objects as organized patterns rather than separate individual components. You may have heard the phrase, "the whole is greater than the sum of its parts." This comes from Gestalt psychology. And I would like you to be familiar with several principles that describe how our brains automatically organize elements into meaningful groups. The first one is pretty straightforward: proximity. We are more likely to perceive objects as a group when they are physically closer together. In this image, you see a bunch of dots. But would you consider the collection to be best described as rows or columns? Well, since they are organized to be much closer horizontally than vertically, we're more likely to see rows instead of columns. Next, we have similarity, which is another straightforward concept. Items in a group are likely to resemble each other on some dimension. Here we have a collection of dots again, and each dot is basically the same distance away from the next. But since some have a solid green fill and others are empty, we again are perceiving discrete rows of dots as grouped by their fill. The enclosure principle relates to whether some visual boundary around the objects exists, which leads us to believe that they belong to a related group. This image shows how enclosure can be established both with lines around objects as well as a shaded background. The Gestalt principle of connection relates to whether objects appear attached. In this example, horizontal lines appear to visually link rows of dots together. Of course, our brains are constantly processing more than one Gestalt principle at a time. Here you can see an example with all of these first 4 we've talked about: proximity, similarity, enclosure, and connection. And at this point, there isn't a doubt in our mind that we must be looking at 4 discrete row groupings of dots. These aren't just 16 individual unrelated dots. Our brains have reflexively established groups. And it isn't just what we subconsciously think. Our very eye movement and attention will indicate that this is how you are looking at your screen right now. Well, these were the first ones. Let's explore a few more. Next is symmetry, which refers to the balanced and mirrored arrangement of objects. When objects exhibit a symmetrical pattern, it appears harmonious and aesthetically pleasing, which is easier for our brains to process. Here, I've actually pitted the principle of symmetry against the principle of proximity. Even though the symbols in the middle are close to each other, they are somewhat dissimilar. More importantly, each sits opposed with a symmetrical counterpart, and our brains recognize that we've got a pair of square brackets and curly braces. Continuity refers to the tendency for our eyes to follow paths or lines in a smooth, uninterrupted manner. Our brains prefer to interpret visual stimuli in a way that maintains a consistent direction or progression rather than abrupt changes. When visual elements are arranged along a continuous line, we perceive them as visually related. In this example, I've now pitted continuity against similarity. Even though we've got different colors in these dots, our brains are going to default to seeing a horizontal line and a curving line that intersects it. Next, we've got closure, which refers to the mind's tendency to perceive a complete, whole object even when visual information is missing or incomplete. When we encounter shapes or patterns with gaps, our brain fills in the missing parts to create a familiar, recognizable form. Here, we don't have just a bunch of independent shapes. Collectively, we view an airplane. You will sometimes see this principle used in company logos. For example, the Adobe logo is intended to look like the letter A, but they don't need to flesh out the entire letter. Our brains are able to recognize it even before I start to round it out here. Another example is IBM. I assume that when you see their logo, you don't just perceive a bunch of blue rectangles, triangles, and trapezoids. You probably do recognize that as a whole, these shapes are spelling out the letters I, B, and M, even with the gaps between the blue. The last one we'll cover is known as figure ground. This refers to our tendency to try to separate objects from a background. Here, our brains are trying to identify some contrast and focus our attention on a figure. This one can be kind of fun, so it gets 3 examples. You've probably seen this first one. Do you see a vase or 2 faces? If you see green as the figure color, you see a vase. But if green is the ground, you'll see 2 white faces talking to each other. Here's another one. You might see either a woman's face or a man playing a saxophone. Again, depending on whether the green is the figure or the ground. This last one is the logo for the Pittsburgh Zoo, and it's pretty clever. The green tree stands out pretty quickly, but as your brain transitions to make the white color the figure, you can see a gorilla and a lion staring each other down. Remember, all of these Gestalt principles deal with how our brains perceive stimuli and organize them into groups. So how does this relate to data visualization? Ultimately, the way that we organize stimuli into groups is important because in some cases, we want related chart elements to be grouped together. In many other cases, we want the opposite. We want a particular category or variable to stand out and draw your attention. A related but discrete topic in this discussion involves pre-attentive attributes. These are other principles that relate to how our brains engage in perception almost instantaneously and subconsciously. Whereas Gestalt principles describe how elements are perceived in relation to one another, pre-attentive attributes help us spot and identify specific features quickly. And the 2 categories we'll discuss here relate to form and color. Form relates to the shape and dimensions of objects. For each of these groups, you can very quickly see which object is not like the others. You can see the contrasting length, width, and orientation of those lines without having to consciously think about them. The shape and size instantly draws your attention and focus. You can also use color to achieve contrast and provide emphasis. You can use different hues of colors. That red dot sticks out among all that blue. You can also use different intensities or saturations within the same color. You can spot out the one dot that has a lower saturation of the same blue color. Color is perhaps one of the most powerful tools at our disposal to emphasize chart elements, but we've got to be careful. It is a two-edged sword. When used judiciously, it can really make things stand out, but if overused, you can end up with a big mess and fail to draw a reader's attention to the elements you care about. We're now ready to move on to the last ingredient of high-quality visualization, simplification, which is defined as the art of taking something that is needlessly convoluted and complex and doing one's best to make it a lot easier to interpret and process and understand. I hope you've seen the irony in this definition. A better definition for such a word might be just making something easier to understand. The reason I include the first definition is to be illustrative. So much of bad data visualization has to do with including the unnecessary. Excessive detail and cluttered design makes a visual difficult to interpret and is more cognitively taxing, just like that definition. The main concept I want you to be familiar with as it relates to simplification is something known as the data-to-ink ratio. This is a well-known term in the visualization space. It's not something you actually calculate, but it's a way to represent the idea that you want to increase the proportion of information conveyed in a visual relative to the amount of non-essential chart elements. Information is the numerator, and it's not like every single visual needs to be packed with loads of insights and takeaways. So honestly, you just think of the numerator as some fixed amount of information that needs to be communicated. In which case, the only way of improving this ratio is by reducing the denominator, or ink. And ink here is talking about if you were to actually print the visual, how much printer ink would be used up. So ultimately, you are seeking to eliminate the clutter from a visual, reducing non-essential elements like borders, grid lines, or other decorative features. This may sound obvious, but you would be surprised by the quality of visuals that are out there. And sadly, Microsoft Excel is one of the main reasons for this. While they've gotten better at presenting simple visuals in their recommended charts in recent years, they still suggest terrible chart styles. And naive users see them, they think they look cool, so they choose them, and they're simply awful. Here's an example that's been taken to an extreme. A 3D stacked bar chart. We have to keep looking up and down at the bars and the legend to know which color is which. The y-axis is hard to read, and the x-axis presents the time fields in a very redundant fashion. And of course, it's hard to miss that doomsday background of pollution. Now you might say that this is ridiculous. No one ever produces content like this. And I'll admit, this one was a bit extreme, but here are some real-world examples. This first one comes from the City of Orem's recently published financial statements. We've got a 3D pie chart with a dozen categories, a lot of random colors, and it's not sorted in any way. This is one of those unfortunate times where constructing a visualization actually slows down the speed with which a reader can process the information, relative to, say, a table. I'm not necessarily saying that a table is the best way of presenting the information, but it serves to demonstrate that if I can more effectively and efficiently process a table relative to a visual, there's something seriously wrong. Here's another one from the same set of financial statements. First of all, with 10 points in time, this obviously should have been a line chart, not a bar chart. It also isn't helpful to have the dark gray background behind each of the columns. You can see that they must have checked the box to put a black shadow behind each column. Again, that choice actually impairs our ability to process the information, as it makes it more difficult to precisely determine the column's height. On the y-axis, we've got 10 tick marks starting at 15 million to 17 to 19 and so forth. I'm not sure we need that many. It squishes a lot of the numbers together, and then we have a lot of zeros being repeated over and over. I took 3 minutes in Excel to try to improve this visual. I've changed this to a line chart and reduced the number of data points being presented. I got rid of the border around the graph. I tried to simplify it by adding data labels to 2 specific years that I think are most important, to show how sharply revenues from sales taxes increased from 2020 to 2023. I'm not saying this is perfect, but I think it does a good job of conveying how reducing non-essential chart elements improves the data-to-ink ratio and increases the effectiveness of the visual. To wrap up, we've now moved beyond just selecting an appropriate visual. We've proceeded to examine additional essential ingredients of highly effective visuals, which involves emphasizing takeaways and simplifying chart elements. We learned how Gestalt principles and pre-attentive attributes can be effective tools to help us emphasize or de-emphasize elements of our visualizations. You need to be familiar with their definitions and be able to recognize each when implemented in an example. And lastly, we discussed the concept of the data-to-ink ratio, which is an overall recommendation to eliminate any unnecessary chart elements in your visuals. And if you can master these principles, you will be well on your way to producing high-quality data visualization.